Today, we have an extraordinary discovery to share that takes us back to the dawn of the universe. NASA's James Webb Space Telescope, or JWST, has uncovered tiny, incredibly bright objects from the early universe that are baffling scientists. What are these objects, and what do they mean for our understanding of the cosmos? Recently, the JWST confirmed the presence of luminous, very red objects that are challenging conventional thinking about the origins and evolution of galaxies and their supermassive black holes. An international team led by Penn State researchers used the NIR SPEC instrument aboard JWST as part of the Ruby survey to identify these mysterious objects in the early universe, dating back to just 800 million years after the Big Bang. The team announced their findings in the Astrophysical Journal Letters, revealing that these objects contain old stars, hundreds of millions of years old, far older than what we'd expect in such a young universe. Additionally, they discovered signatures of massive, supermassive black holes, estimated to be 100 to 1,000 times more massive than the black hole at the center of our Milky Way. Lead author Bingji Wang, a postdoctoral scholar at Penn State, expressed amazement at the discovery, stating, "We have confirmed that these appear to be packed with ancient stars, hundreds of millions of years old, in a universe that is only 800 million years old. Remarkably, these objects hold the record for the earliest signatures of old starlight." This discovery was unexpected and challenges the standard models of cosmology and galaxy formation. Joel Leja, assistant professor of astronomy and astrophysics at Penn State, highlighted the peculiarity of these findings. "You can make this uncomfortably fit in our current model of the universe, but only if we evoke some exotic, insanely rapid formation at the beginning of time. This is, without a doubt, the most peculiar and interesting set of objects I've seen in my career." The JWST's infrared sensing instruments allow scientists to see back in time, roughly 13.5 billion years, near the beginning of the universe. Analyzing ancient light is challenging, but the unique characteristics of these early objects suggest they contain both supermassive black holes and old stars. Wang explained that distinguishing between light from material falling into a black hole and light emitted from stars is challenging, leaving ample room for interpretation. One of the fascinating aspects of these discoveries is the surprising mass and age of these objects. If part of the light indeed comes from supermassive black holes, then they aren't your typical supermassive black holes. They produce far more ultraviolet photons than expected, and similar objects studied with other instruments lack the characteristic signatures of supermassive black holes, such as hot dust and bright X-ray emission. But perhaps the most surprising thing is how massive they seem to be. Normally, supermassive black holes are paired with galaxies. They grow up together and go through all their major life experiences together. But here, we have a fully formed adult black hole living inside what should be a baby galaxy. That doesn't really make sense, because these things should grow together, or at least that's what we thought. The researchers were also perplexed by the incredibly small sizes of these systems, only a few hundred light years across, roughly 1,000 times smaller than our own Milky Way. The stars are approximately as numerous as in our Milky Way galaxy, with somewhere between 10 billion and 1 trillion stars, but contained within a volume 1,000 times smaller than the Milky Way. Leja explained that if you took the Milky Way and compressed it to the size of the galaxies they found, the nearest star would almost be in our solar system. The supermassive black hole in the center of the Milky Way, about 26,000 light-years away, would only be about 26 light-years away from Earth and visible in the sky as a giant pillar of light. These early galaxies would be so dense with stars that must have formed in a way we've never seen, under conditions we would never expect, during a period in which we'd never expect to see them. And for whatever reason, the universe stopped making objects like these after just a couple of billion years. They are unique to the early universe. The researchers are hoping to follow up with more observations, which they said could help explain some of the object's mysteries. They plan to take deeper spectra by pointing the telescope at the objects for prolonged periods of time. This will help disentangle emission from stars and the potential supermassive black hole by identifying the specific absorption signatures that would be present in each. Imagine the excitement of peering into these ancient objects and unraveling their secrets. There's another way that we could have a breakthrough, and that's just the right idea. We have all these puzzle pieces, and they only fit if we ignore the fact that some of them are breaking. This problem is amenable to a stroke of genius that has so far eluded us, all of our collaborators, and the entire scientific community. The significance of these discoveries goes beyond just understanding these tiny, bright objects. They also provide crucial insights into the formation and evolution of galaxies and black holes in the early universe. By studying these objects, scientists can refine their models of galaxy formation and gain a better understanding of the conditions that prevailed in the universe's infancy. This discovery also also highlights the incredible capabilities of the James Webb Space Telescope. As the most advanced space telescope ever built, JWST is revolutionizing our understanding of the cosmos. Its ability to peer into the distant past and uncover hidden details about the early universe is nothing short of extraordinary. The telescope's infrared sensors allow it to detect light from the most ancient stars and galaxies, providing a window into the universe's earliest epochs. As we continue to explore the cosmos with JWST, we can expect more groundbreaking discoveries that will reshape our understanding of the universe. The tiny bright objects discovered in the early universe are just the beginning. With each new observation, we move closer to unraveling the mysteries of the cosmos and gaining a deeper appreciation for the complexity and beauty of our universe. Thank you for joining us on this journey from the dawn of the universe to the intriguing discovery of small bright objects. If you found this video informative, please like and subscribe to our channel. Don't forget to hit the notification bell so you don't miss updates on our latest discoveries, and see you in the next video.